This episode of Photonics Hot List is brought to you by Edmund Optics, where custom manufacturing is supported by a comprehensive range of measurement capabilities, including in-house laser damage threshold testing, custom-built industry-leading spectrophotometers, and aspheric stitching interferometry with less than 20 nanometers of uncertainty. Learn more at edmundoptics.com/manufacturing.
Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Efforts to protect consumers from contaminated foods rely heavily on approaches that screen for harmful pathogens. But some of them, including cell culture and DNA sequencing, lack the high accuracy needed to guarantee public health. Now, new sensor technology could make detecting pathogens much more effective. Researchers led by a team from Guangdong University of Technology in China have designed a microfluidic chip that uses light to simultaneously detect multiple types of pathogens in food. More specifically, the new chip, created via 3D printing, is an aptamer-based nanointerferometer that identifies 4 foodborne pathogens: Listeria, E. coli, Salmonella, and Staph A. The chip features 4 sections, each customized to detect those specific pathogens. When any are identified, they bind to the chip's highly sensitive detection surface, where changes in their optical properties provide precise details. The researchers say their 3D printed chip sensor has already proved to be highly accurate, offering rapid results with a more cost-effective setup. Attempts to avoid acquiring useless data outside of targeted regions of interest have led to new technology researchers in China say could enhance in vivo biodynamics imaging. The team from Tsinghua University has developed a flexible, compact, random access wide-field mesoscope capable of imaging samples of various shapes, sizes, and orientations in vivo. The system involves an infinity-corrected objective of a high space bandwidth product, as well as commercial lenses and 2 custom-designed lenses for larger aperture and minimal aberration. The setup supports several imaging modes: dual color fluorescence, bright field imaging, and dark field imaging. Dividing a whole field of view into multiple subfields ensures high spatio-temporal resolution. And while the Mesoscope's camera mixes continuous exposures of multiple subfields of view, the data obtained is transferred just once. Signals for each subfield of view can be computationally separated as well, based on the spatial distributions of neuron or blood vessel samples. The researchers say this new mesoscopy approach will ultimately advance biodynamic studies in vivo in areas such as neuroscience and immunology. Topological insulators, the interior of which act as electrical insulators and the surface as an electrical conductor, have long exhibited quantum properties as well as exciton polaritons, hybrid quasiparticles of photons and excitons. But by shifting such components further into the photonics realm, a team from Rensselaer Polytechnic Institute in New York aims to expand quantum research and capabilities. The researchers have developed a photonic topological insulator that can prevent photons from scattering throughout a material. This makes them coherently behave like a single photon and essentially protects the unimpeded flow of electrons along the edges without dissipation and backscattering triggered by impurities. The device's design process involved growing ultra-thin plates of halide perovskite containing cesium, lead, and chlorine, and etching a polymer on top. The perovskite plates and polymer were placed between sheets of different oxide materials that became just 2 microns thick and 100 microns in length and width. In their work, the researchers observed long-range spatial coherence of quantum fluid and also demonstrated topological protected edge states at room temperature without an external magnetic field. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. And check out our Following the Photons podcast too, to hear some really interesting interviews with the industry's top players. Until next time.